morning. Hope you are having a great time. I know it's the second day of the conference, so a little bit tired, and some of you might be overloaded with the information gathered by listening to these great speakers. Even personally, I learned a lot yesterday. I'm Asanka Abeysinghe, Deputy CTO and the VP of Architecture at WSO2. WSO2, we are a technology company providing various open source integration technologies and working with many organizations, partnering with them as a technology partner and helping them on their digital transformation journey. But today I'm not planning to talk about WSO2. So I picked a different topic. If you look at the agenda, it's a little bit different, but I felt it's relevant and connected with the APIs. So during next 25 minutes, I'll tell this story about a middleware developer. Are there any middleware developers in the audience? Anybody? Oh, okay, few. Any middleware users? Okay, so I think then I'm in the correct place. So I'll start this story February 1997. So I think it's not relevant for you, but very important for me. So I started my career in this day. So when I entered to this software company, a small to medium-sized software company, and this is what I saw. I think most of you know what this is. It's a Wang VS system. So I was really disappointed because that's the era object orientation came into the picture and people coding using Visual Basic. So I was expecting something to do with that, but it changed during the week. So during the first week, couple of technical managers talked to me and explained why they did hire me. So it's basically this 3T architecture. Today it's nothing, but those days it's kind of really important. So they said they are planning to move the COBOL systems into this 3T architecture, reuse some of the databases, like they used, it's not working, yeah. So the databases they used in the COBOL systems and then connect with, use object COBOL to write the business logic, and then revamp all the very boring COBOL user interfaces using Visual Basics. So they asked me to do a POC and then do a productization of the same tool, and we try out with different technologies, use the COBOL data access technology to connect with the databases, and then use first start with OLE, and then use the COM Plus, and ended up using DCOM to connect with the Visual Basic layer from the object COBOL layer. So then the prototype was successful, then started productizing this, and my manager told me, you are working in the platform department and you are a middleware developer. So I didn't have a clue about what I am doing, but I did like it because the senior or the experienced developers were using the code that I am writing, so I was really happy. Then the end of the month came. So usually end of the month you get the paycheck, and then I got it, and the first pay. So I went home, and during the dinner table, my mother asked what we are doing. Now, if I was a hardware developer or a hardware engineer, it's easy to explain what a hardware engineer is doing. If I was an application developer, it's easy to explain what's the application developer doing, because even those days people using spreadsheets. But how to explain the middleware developer, I tried a couple of times, but it didn't work. Then I came up with a nice analogy. Still I am using it when I am teaching middleware as well as doing an introduction program for a new employee. How and what is middleware? So I'll use the same concept here. So it's about a stadium. Okay. So actually this is the Levi's Stadium. I live next to this stadium in Santa Clara, California. So this is the home of 49ers, the great football team. So during the season, they play a lot of games in the stadium. And when the off season comes, they host many events in the same stadium, like a motocross or kind of a supercross event. And in some nights, they run these kind of concerts. So this is Coldplay playing there. So what's a stadium doing? It's basically providing a platform to different people to perform. Okay. So they use the infrastructure and then they use the setup there and then host many events for these people to perform, as well as it's connecting an experience. So when I explained this to my mom, she understood, and then I went to the software layer and explained, okay, I'm creating a platform for people to perform or write different kind of software applications, and then using these applications, end users are experiencing a different experience. So it did work well. So, and Wikipedia again explaining something similar. The middleware is the glue of software. And then it's explaining something really important. The application developer can focus on the business logic and then improve their application, while the middleware developer will focus on the middleware and increase or improve the capabilities of the middleware and then make the application developer productive. So, and then we used to use a lot of middleware. I think message-oriented middleware is common. And then database-related middleware, again, something common that a lot of people using. But there are many other stuff that like subcategories contains in the middleware as well. So I think most of you guys have followed this the stories about asterisks. So the moral of the story, these two guys, they provide the same power in different forms. One guy is energetic by nature. The other guy get the energy drink and become energetic. So based on the situation, they use their power. So the same concept came to the middleware as well. Middleware users were expecting the middleware has to be customized based on the nature of the functionality that they are expecting, as well as where they are planning to deploy this middleware. So with that change, I started working on 2008 fall, this interesting project called Carbon. So what we did in that project, changed the way we develop the middleware into a more modularized way. So we use this technology called OSGI. That's a framework that you can use to develop modular Java-based applications. So the people who use this middleware stack, they started customizing. They started adding functionality when they required, and then when they want to deploy this in a limited environment like a client side, they started removing the unnecessary capabilities and started optimizing the functionality of this stack. So that was a change happened. And if we look at today, what's really happening now, I didn't hear a single word about middleware during yesterday's sessions. We talk about APIs, we talk about service meshes, we talk about containers, microservices, but we don't hear middleware. But as an application developer, you know that the functionality of the middleware is required to be productive as well as to build these different kind of application software. So what I'm going to share is a very opinionated view in the next slide based on my experience, because my entire career I spent as a middleware developer. Based on this experience, I have a very opinionated view of what's really happening in the middleware. So this is what I think middleware is disappearing. So it's disappearing into two levels. One is into code. I think yesterday one of the keynote speakers touched based on that. What's happening there. And then the next belief is middleware is disappearing into the infrastructure. When it's disappear or the apply to the code, it's more simple and constructive. A developer can use it like they are using a normal programming language. And then when it goes to the infrastructure, you can scale, you can manage, and then it automatically provides the observability layer. So I'll be using this slide a couple of times because there's a saying, once you repeat something, it kind of resonates well. So let's see how it goes. So now with this change that we think what's happening with the middleware, it's kind of influencing different layers. People means the developers and the architects or people who involved in the projects. It's changing. So we talk about this full stack developer today, not like a developer 10 or 5 years back. Today developer has a bigger challenge because they have to learn about the infrastructure, they have to learn about DevOps, they have to learn about the database technologies, and then front-end development and service development as well. Because developer engage with the entire life cycle of application. And they plan, they develop, they run, they manage. That's how the culture and the expectation from a developer. So it's affecting in another angle as well. Each and every developer should have some kind of architecture capabilities, and then development capabilities obviously, and then they should have knowledge about the deployment as well. Then the person or a full stack developer, in a way he's an architect, he's a developer obviously, and then he's a DevOps person as well. So some of the architects, they don't like this, but I think that's what's really happening in the industry. Then the process-wise, it's changing again with the change of the middleware. So what's happening during the service-oriented architecture era, we introduced a lot of governance, right? It's entire service-oriented architecture starting from the contract or a WSDL. It's about the governance. And governance is interrupting the productivity or the flow of this rapid application development. As well as lot of organizations, they follow different kind of agile methodologies, but recent research identified that only 4% from this organization getting the full benefit of agility. The problem is these middleware stacks. So we deploy these middleware stacks, and then it created the layered architecture. Not only a technology level layered architecture, it created organization structure with these different layers, because each and every layer owned by a different team. In other words, we call it as a center of excellence. So to get something done, you have to pass these layers, and layers creating gates. And gates are slow downing the flow. So that's the main problem. And even organizations think they are agile, but they are mainly fast waterfall or waterfall agile. Some people call it as agile. So this is happening in the industry. So the agility is about the developer flow. How a developer can be productive, how quickly he can release a new feature, or how quickly he or she can fix a bug and release a patch or a new version of the product. So there are two primary metrics that you can use to measure this thing. One called the flow metrics, basically identify the wait time and then the productive time and get the percentage out of it. And if you really look at the wait time is really high in an organization because they have to wait or depend on another team. And the second thing is called the MTTR, mean time to repair. So how quickly you can fix a bug and release the product is the next thing that you can use to measure the productivity of a developer. And then the next thing is we use configuration driven stuff using last 2 decades, but nature of a developer is developers love to code. Okay, so if they are happy, then they are productive. So we see a huge movement from configuration-driven nature into code-driven approach today based on this productivity that we are looking at. So it's not a single developer productivity, right? Because we need a product team. And they have to work together, and then they have to move in the same phase to be more productive. So it's about the how they are adopting and then moving in the same phase in a product team, and we call it as a self-organized teams. People use many terms like Scrum teams, pizza teams, but we call it as a self-organized team. And the technology-wise, also this movement of middleware is impacting. So what's really happening, this wrong technology stack, it can be the layered architecture that you are using or the centralized deployments that you are using to deploy everything. So it's changing as well. So the architecture is moving into more decentralized architecture. We call them as architecture blocks. And these architecture blocks enabling the organization to be more composable, and API is the key because it connects all these different kind of architecture blocks together. I'll go in detail in next few slides about that. So that is the movement happening in the technology. And now you have a decentralized architecture. So you have a lot of moving components. That's where the communication is coming very important. And I think most of you are familiar with service mesh technologies. So why they are in the picture because of this need that we have in the communication. So I use to explain again how I tell my mom about control planes, data planes, and management planes. I use this the analogy about a train track. So if you look at the train is the actual component that take the people, that's the data plane, and the train track is how the data movement happens, that's the control plane, and there's a management plane which control and provide the policies and do the monitoring, that's the management plane. So with these different architecture blocks, there should be an intra and intercommunication. I think service mesh is only addressing part of this problem. So we dig in deep into this problem, and we believe within the architecture block, there should be a control plane and a data plane, and then there should be a control plane and data plane at the global level and connect with the management plane. So we name it as global mesh and a local mesh. You can use different technologies to implement it. This is just as at the architecture level how we can identify these two layers. And the API is coming here because this is completely an API-centric architecture. The service to service or component to component communication happens using an API, as well as the components connect with the user interfaces using an API. So even yesterday, some of the speakers explained about different types of APIs. Even I am in the same page. It's not about request response. We have passed that level. So it has to be pull APIs as well as push APIs, implement using request response as well as event and streams by using different kind of technologies. That's where the API come into this picture, connecting the north to south as well as east to west communication between these components. So I'm not using these terms called microservices or any gateways, so and so forth. In this architecture level, we treat everything as a component. So it can be a function, it can be a microservice when it comes to the implementation. So middleware is disappearing. I'm going to repeat the same slide into the code and into the infrastructure. So with this belief, we started working on it. So that's where these 4 projects came into the picture. The first thing is Ballerina. So what we have done with Ballerina, basically we embedded the middleware into the code. And then there's another project that working on called Celery. That's basically how you embedded middleware into the infrastructure. And now you have 2 frameworks, but you need to architect these systems. So there we introduced something called a cell-based architecture, and then agile methodology to implement the cell-based architecture. So first 2, Ballerina and Celery, I have contributed to these 2 projects, but the last 2, cell-based architecture and agile methodology, those 2 I authored with the help of my CTO as well. So if you look at Ballerina, we position it as a cloud-native programming language that you can use it to write microservices, write integration microservices. Integration microservices are like the basically composite services if we look at it from the SOA world, and then you can use it to connect with various endpoints. And we believe a developer today is an integration engineer, because most of the functionality is available somewhere as an endpoint. It can be a cloud service, it can be a data service, or it can be some kind of an API. So as a programmer or a full stack developer, what we are doing is connecting with these different kind of endpoints. So Ballerina can use it as a very productive way to connect with these endpoints, because the middleware is embedded in the language that you don't need to worry much. As an example, some of the data types in Ballerina, the native data types are XML, JSON, so you don't need to worry about parsing those things. It's embedded within the language. And another very important thing in this language is the graphical parity of it. So you write the code and it generates a sequence diagram. So the problem with network programming, it's really hard to represent a network program in a data flow diagram. So we identify sequence diagram is a really cool way that even for the programmer, he or she can use it to identify the diagram identify the flow, and then if she or he wants to explain this logic to somebody else, they can use the sequence diagram as well. And I think most of you have been to the Ballerina talks and then the booth, so you must have a fair understanding about this. So this is the next effort that we are working on, basically moving the middleware into the infrastructure level. So this is first targeted Kubernetes, but we are planning to improve it for other infrastructures as well. It's basically how you can take this architecture block into a composite and then go and deploy. So we are using CRDs in Kubernetes to represent one architecture block and go and deploy this in different infrastructures. So basically, it's a replacement for the YAML. I think people using YAML, but nobody is happy with YAML. So this is an alternative that you can use this code approach and then use Ballerina as an infrastructure as a code, and it generates this graphical representation of your deployment as well, with what are the components you deployed and what are the dependencies, so on and so forth. So that's another effort that we are working on. Then the architecture. So this is the cell-based architecture. Basically represent that architecture block in a detailed way. So if you look at cell is a collection of components. As I explained you earlier, anything that you run as a runtime, we treat it as a component. So and a cell contains a gateway. So all the ingress calls will come through that particular gateway, and then you can apply policies there. It's basically how you can control these different kind of components. And then if you look at the enterprise, adopt this thing and then build, become a cellular enterprise, it will look like this, lot of cells running in different, providing different capabilities, and you can have different cell types as well. Based on the functionality, you can name them as a logic cell or a channel cell or a legacy cell, so on and so forth. Then the reference methodology, I usually treat reference methodologies as a GPS system that you can refer and then identify where you are. To identify where you are, we have a maturity model. And most of the reference methodologies talk about people, process, and technology, but we extended it by identifying culture and technology is the platform for people, process, and technology. And once you improve people, process, and technology, it provides a digital alignment for your organization. That's how this methodology has built. And this is the maturity model. It's a two-dimensional thing. Once you go into the spec, you will find more and more information. And the methodology and the architecture nicely connect. We talk about a self-organized team. A self-organized team can own a cell or multiple cells, but a cell cannot be owned by two different teams. So there, the APIs coming back into the picture as well. How two different teams will communicate, they will communicate by using the APIs exposed by a team by using a single cell or multiple cells. So again, I'm repeating, middleware is disappearing into code and to infrastructure. So with that thing, the power of API going to the next level. So API is becoming the glue of these micro components deployed in a decentralized architecture. So it's playing a massive role. So last but not least, I would like to invite you to consume these projects and contribute as well. All these are in Git. Basically, the Ballerina and Celery released under Apache 2.0, and the two specifications released under Creative Commons. So we are expecting you to consume and apply it in your projects, and if you are happy, you can give a Git star, as well as if you think you can contribute by providing an improvement or correction in the specifications or these projects, you can send a pull request.